Okay, welcome to today's lesson. I would like to start with a startup here. We don't do that every day, but I'd like to start with one. And this one is finding the x-intercepts, y-intercepts, and symmetry. So if you'll go ahead and try this and then check your answers. Okay, these are the answers that you should have gotten. So on the x-intercepts, just to recall, you want to let y equals 0, substitute that in and solve, and you get x equals plus or minus 2. We can write it as an ordered pair like this. And then if you find the y-intercepts, you let x be 0, so put 0 in for x and solve that. Remember when you take the square root to do plus or minus, and you get the y-intercepts of 0 and plus or minus 3. As far as checking for the x, y, and origin symmetry, if we look at that, just a reminder for the x-axis, you substitute negative y for y, simplified, and if it equals the original, then it has that type of symmetry. So it does have x-axis symmetry. For y-axis, substitute negative x for x and simplify. And when you do that, you see that it does equal the original. So it has y-axis symmetry. And then for the origin, you're going to substitute negative x for x and negative y for y. Simplify that, and that one also equals the origin. So this particular one is actually an ellipse, and it does have all three types of symmetry. Okay, today we're going to be looking at section 1.10, and this is dealing with lines. Most people tend to like this section because you usually have a lot of experience with lines and writing equations of lines and so forth. So I'm going to go through quite a few examples just to refresh your memory, but it should be a review for you today. Okay, we're going to start by talking about slope. So the slope of a line is often referred to as rise over run. So with the slope, you look at how it changes vertically over how it changes horizontally. So if you're going to look at this, then if you've got a positive slope, then you're going to have a positive rise over run, and it's going to rise from left to right. And if it falls from left to right, then you're going to have a negative slope with that. So this one would have a positive slope, and this is going to have a negative slope. Okay, so the definition, the slope of a non-vertical line, because we'll have to do vertical lines a little different, that passes through these 2 points is defined as y2 minus y1 over x2 minus x1. This is a formula you really should know. I'm not going to require that you know it because it's on your formula sheet, but it's used so often you really should know that. And a vertical line has a slope that's not defined because what happens is you have no run on a vertical line, so you have a 0 in the denominator, and that's why a vertical line has a slope that's undefined. Right, so this is just kind of showing you that regardless of the 2 points you pick on a line, they're going to have this, if it's the same line, then they're going to have the same slope. So I could pick these 2 points, or I could pick these 2 points. It's not going to matter. The slope's going to stay the same. Okay, we mentioned that if it rises from left to right, it has a positive slope, and if it falls from left to right, it has a negative slope. But if it stays flat, if you have a horizontal line, then it has a slope of 0. And we typically refer to slope with an m, so your m is going to be 0 here. And this one, your slope is going to be undefined or no slope. So just watch your directions on WebAssign and make sure that you're entering it the way that it asked for, because we all know that it can be picky at times with that. So this is going to be a vertical line, and the vertical line is going to be an undefined slope. Okay, so here's an example that I'd like for us to look at, just calculating the slope of the line. Okay, looking at this one here, when we go to calculate the slope of the line, we have our formula off to the side here that we're going to be using. So this is going to be our x1 and our y1. This will be our x2 and our y2. So to calculate the slope using this formula, we'll start with our y sub 2. So that'll be 5 minus y sub 1 will be 1 over 8 minus 2. So we're going to have 4 over 6, and we'll have 2 over 3. So for every 2 units that it rises, it's going to run 3 units. We have a positive slope, so we expect it to rise from left to right. So this is the line that we just calculated the slope of. And I wanted to mention here briefly, if you look at the rise, if we rise 2 and run 3, you can see that rise 2, run 3 is going to take us to each of those points. If I keep doing that over and over again, then I'm going to end up with different points on this line. Okay, so the most of our focus today is going to be writing equations of the lines. So in order to write the equation of the line, the easiest form is the point-slope form of the line. You may have worked with slope-intercept or the general form. Personally, the general form is not as user-friendly. I do like slope-intercept as well, especially if you're graphing a line. Slope-intercept is an easier form to use. But if you're writing the equation of the line, I think point-slope form is the easier form to use. So point-slope form, it is included on your formula sheet. It's y minus y1 equals m times x minus x1. So a couple things to keep in mind here. M is your slope. Whatever your slope is one thing that you have to have. So you have to have your slope. The other is you have to have a point. So I'm going to have to know a point, and those coordinates are going to be substituted in for the x sub 1 and y sub 1. I do not have to substitute anything for the y and this for the x. Those are going to stay as part of my equation. So in order to write the equation of the line, at a minimum, you're going to have to know a point and a slope to be able to do this. Okay, so on this one, we have a point given to us and we have a slope. So this is our x1, y1, and our slope is m. So I want to go through and write the equation. So I'm going to start with the point slope form of the line, which you'll see here. Okay, and I'm going to make those substitutions. So it's going to be y minus a negative 3 equals negative 1/2 times x minus 1. Here my two negatives make a positive, so I've got y plus 3 equals negative 1/2 times x minus 1. I'm actually going to wait and move that on the next step. So this will be, I'm going to distribute here, so negative 1/2 x plus 1/2, and then I'm going to subtract 3. And don't be afraid to just pull out your calculator if if you have trouble with fractions, just use your calculator. So 1/2, subtract 3 from both sides. So 1/2 minus 3 is going to give me negative 2.5, which is negative 5/2 for my answer. So this is in slope-intercept form, and so this is my slope, and this is my y-intercept that it's given me here. So this will be my final answer for this particular problem. Okay, this is the graph of this. We said that our y-intercept was negative 2.5. So we're going to start here, and we had a slope of negative 1/2. So that tells me I'm going to go down 1 and over 2. And so I end up with a point here. So since it's a negative, I go down and then to the right, and that gives me this negative slope here. All right, so we mentioned slope-intercept form. Slope-intercept form is y equals mx plus b. Point-slope form I think is best for writing the equation. Slope-intercept form I think is best for graphing the equation. So we want to be familiar with both. So when it's in this form, y equals mx plus b, your m is your slope and your b is your y-intercept. So you can easily see the slope and the y-intercept, and those are really the two things you need in order to be able to graph it. Okay, so this one you would want to write an equation of the line with a slope of 3. So this is my m, and a y-intercept of negative 2. So that's my b. So if I use y equals mx plus b, since I have the slope and the y-intercept given, it's actually easier to use slope-intercept form on this one. So I'll have 3x minus 2 for my answer. If I wanted to go back to point-slope form, I could. So I want to show you that here. If I have a y-intercept of negative 2, that means it's touching the y-axis at negative 2. So my coordinates would be 0, negative 2. So this would be my x1 and my y1. So I'll have y minus a negative 2 equals 3 times x minus 0. So I still get 3x minus 2 for my answer on that. So it just depends on if you realize that that you have the slope and you have the y-intercept, you can plug that in here pretty quickly. If you don't realize it, convert that to a point and then use it and you should be fine. Okay, here's when we want to find the slope and the y-intercept of this particular line. So this line, in order to put this in slope-intercept form, which is going to be the easier form to use to find these things, we need to solve it for y. So we're going to put this in slope-intercept form. And we're going to do that by solving for y. Okay, so I've got 3y minus 2x equals 1. So I'm solving this for y. I want to move the 2x over. And I'll divide by 3. So y equals, I do like to split this up, so 2/3 x plus 1/3. And so I have it in this form, y equals mx plus b. So m, which is my slope, is going to be 2/3. And b, which is my y-intercept, is going to be 1/3. Okay, vertical and horizontal lines are special types of lines. So a vertical line is going to have the equation x equals, and it's going to be the first coordinate or the x coordinate of my point. If I have a horizontal line, then it's going to be y equals, and it's going to be the y coordinate of my point. So if I have this, let's think about this point here. So we have the point 2, 3. If I want a vertical line through this, and again, I apologize for not being able to draw straight lines. A vertical line is going to be in the form x equals, and the x that it equals is the x coordinate of my point. So it's going to be x equals 2. If I want a horizontal line that passes through this same point, it's going to be in the form y equals, I'm going to take the y coordinate, so it'll be y equals 3. The reason for that is every point along this line, and there's infinitely many of those, they all have the y coordinate of 3. All these have an x coordinate of 2. Okay, so here's a couple vertical and horizontal line questions. So we want to find the equation for a vertical line. So that tells me it's going to be x equals, and we want it to pass through this. So it's going to be x equals the x coordinate. So x equals 3. Okay, next we want to find the x-intercept of the equation x equals 3. So if we think about this, we've got a vertical line here at x equals 3. So the x-intercept is going to be this point here. So the x-intercept is going to be the point 3, 0. Okay, if we want the equation for a horizontal line through this given point, we know horizontal lines are y equals, and we want to use the y coordinate, so y equals -2. And finally, if we have the y-intercept of the equation y equals -2 is going to end up being 0, -2. If you were to sketch this out, we have this line here at -2. Then our y-intercept is here at the point 0, -2. Okay, the general equation of a line, personally, I don't prefer this in very many situations. Sometimes it's asked for with the direction, so just be careful about that. But a linear equation in the variables x and y is an equation of the form ax plus by plus c equals 0, where a, b, and c are constants, and a and b are not both 0. So with this, you're going to have everything pulled over and it's going to be equal to 0. So your x and your y are going to be on the same side, and your a and your b are not going to be fractions. They need to be multiplied out so that they're not fractions. And we'll work with some to show you what I mean with that. But this is the general equation of a line. Okay. So if we want to sketch the graph of this equation, this is in the general equation form because we've got ax plus by plus c equals 0. So if we're going to graph, I suggest putting it in slope-intercept form, y equals mx plus b. So we'll solve this for y. So we'll take the 2x to the other side, and we'll take the 12 to the other side. We'll divide by -3, and we'll get y equals 2/3 x minus 4. Okay, so as far as graphing this goes, we're going to start at a y-intercept of -4, and we're going to go up 2 for the rise, because this is our rise and this is our run. So we'll go up 2, and we'll go over 3 and put our point, and then we're going to connect these together. And that would be the graph of this line. Okay, moving on to talking about parallel and perpendicular lines. Parallel lines, we know, are two lines like the railroad tracks that never touch. Okay, and in order for them to never touch, they actually have to have the same slope. So that's an important concept as we start looking at some of these problems. On this one, we're asked to find the equation of a line through this point, and it's parallel to this line. We said in order to write an equation, we need two things. We need a point and we need a slope. Okay, so our point is given to us. The point we're going to use is 5, 2. We don't have a slope. We're asked to use this line and the fact that we want it to be parallel to that line to get our slope. So I'm going to take this equation that's in general form, and I'm going to put it in slope-intercept form. Okay, so this is the slope-intercept form. We've got y equals mx plus b. So this is my slope, and that's really what I need here, because the slope of this line is -2/3, the one that they give me. But the one that they want me to write the equation of is parallel to that. So because it's parallel to that, it means it has the same slope. So for this one, I'm actually going to use the -2/3 as my slope to then write the equation of this line. So I'm going to have y minus y1 equals m times x minus x1. So y minus 2 equals -2/3 times x minus 5. We're going to distribute. And then we're going to move our 2 over. And again, don't hesitate to go ahead and use your calculator to do this. So 10/3 plus the 2 that we're moving over is going to be 16/3. So that's going to be our equation of the line that is parallel to the line they gave us, but that passes through the point 5, 2. Okay, talking about perpendicular lines. Perpendicular lines we know form a right angle here. So two lines with slopes m1 and m2 are perpendicular if and only if we multiply them together and they equal -1. So basically their slopes are what we're going to call negative reciprocals of each other. So if I have a slope of 2/3, then the perpendicular slope to that is going to be -3/2. So I flip this and I change its sign. If I have a slope of -4/5, then the perpendicular slope to that is going to be +5/4. If I have a slope of 1/3, then the perpendicular slope is going to be -3 or -3/1. If I have a slope of -4, then the perpendicular slope is going to be +1/4, because this is over 1. So if I flip that and change the sign, then I get +1/4. Okay, so this is one that is sketched out for us here to look at. So if you look at this, then our right angle that we need to show is here where PR and QR intersect each other. So we need to go back and look at PR and QR for this part. So we want to look, like I said, at PR and at QR, the slope of those. So PR, we've got here's P and R. So if I'm finding the slope of that, then I'm going to have y2 minus y1 over x2 minus x1. And so I'm going to have 2 over 8 or 1/4. If I look at Q and R, then my slope is going to be y2 minus y1 over x2 minus x1. So this is going to be negative 12 over 3, and that's going to be negative 4. So if I look at this slope and this slope, these are negative reciprocals of each other. And so what we've basically said is that PR is perpendicular to QR, and therefore it would have to be a right triangle because of that. Okay, so looking at this, we want to find the equation of a line that's perpendicular to the line that's given and passes through the origin. We know the origin is the point 0, 0. So in order to write the equation, I need two things. One is a point and one is a slope. So my point, they tell me, is the origin, and the slope I'm going to have to get from this. So I want to put this in slope-intercept form. So I'm going to go through and solve this for y. So I'm going to get y equals negative 2/3 x minus 5/6. And I'm just reducing the 4/6 to 2/3. I kind of did that all in one step. So this is the slope of this line. But I don't want it to be the same slope because I need it to be perpendicular to that line. So I'm going to use this slope that they give me, but I'm going to find out the perpendicular slope. So we want the negative reciprocal of this, and that's going to be positive 3 over 2. So that's the slope that I want to use for my problem over here. Okay, so I'm going to do y minus y1 equals m times x minus x1. So y minus 0 equals 3/2 times x minus 0. So I'm going to get y equals 3/2 x. Okay, this is kind of a lead in to some of the problems that we're going to be doing shortly, where we're looking at modeling using linear equations. But a swimming pool is being filled with a hose. The water depth in the pool T hours after the hose is turned on is given by this equation. So we want to look at finding the slope and the y-intercept of the graph of this equation. So looking at this, this is my slope and this is my y-intercept. Okay, so this is my slope and this is my y-intercept. So the slope we said is going to be 1.5. And because it's the slope, it's going to be, that should be feet. So it's going to be in feet per hour. And then the y-intercept is going to be 2 feet. And so that's basically what the slope and the y-intercept are representing. The slope is representing how fast the water is pouring into the pool, and the 2 is representing how much we had when we started filling the pool. Okay, so it had some water in it at the beginning, and so 2 was the amount that it had in it at the beginning. Okay, here are some practice problems. I'm not going to go through and talk through every one of them. I'm just going to kind of show you these. If you want to practice them, then try practicing them. If not, then you can go on and start with your homework.